In this lesson, we're continuing to solve word problems. We've already developed logarithmic and exponential equations when we're given a word problem, but today we're going to talk about if we're given a table with the data. The data is in a table. The following data represents the prices of computers and the demand for them at a computer store. So here's the price of the computer and here's the demand, or the number of computers that they have sold. Of course, the larger the cost, the fewer the sales. When they lower the cost, they sell more. Now, there's different features and all that kind of stuff involved there, but that makes sense, right? The more expensive something is, the fewer you're going to sell. The first value usually in a table is the independent variable, and that's the case in this one too. Because the demand, this number depends on the price you set for your computer. So this is independent, but the number you sell depends on the price that you set. Notice that the x values are decreasing. We need to rewrite the table so they're listed from low to high, because when you think of the x-axis on the leftmost side, this is going in the wrong direction. So we always start graphing from the low number to the high number, so we need to rearrange that. So right now you need to rewrite this table. This should be your first data entry in your table, and this should be your last, because we need to make sure we go from low to high. So can you take a minute, please, to rewrite that table? Here's what your table will look like once you have it all in order. And now we can tell if it's an increasing or decreasing function. So as our x's increase, which they should be, as our independent variable increase, what's happening with these numbers? Oh, they're getting lower, right? The higher your price, the lower the demand. So this is a decreasing function. And if you hadn't rearranged it and I'd ask you that question, you might just look at these numbers and say, oh, look, it's increasing, because these numbers are getting higher, so it's an increasing function. Here's the data entered into a table in Desmos. Is it clear what type of function you could use? It isn't really. We're going to look at a bunch of them, these four here. So let's start first with linear. We could use line of best fit here. We could try. So let me just put a quick line, quick line through here. Whoops, something like that. Okay, we could say that this is linear. This is a line of best fit, of course. It's not exactly linear. And how would we get an equation? Well, the equation of a line is y equals mx plus b. And we would get the b value from right here. So I would kind of estimate what that number is there, 200 and something. I would estimate that. And then to count, that's how I get the b value. And then to get the slope, I would use my slope formula, y2 minus y1 over x2 minus x1. And I would use any of these points here. Maybe this 1200 would be my x1, and then 180 would be my y1. Here's an x2 and a y2. Pick whatever pair you like, calculate the slope of the line. So that's one way to do it. That's linear. So it certainly could be represented with a linear relation. I don't have enough points to really see any further beyond what's here. Let's talk about quadratic. So could we represent this with a quadratic equation? Well, sure. I'm going to call this point here my vertex, and then if I just curve in this direction and mimic it on the other side, yeah, I could say that that's quadratic. My vertex then is this coordinate right here. This would be my vertex. So if I was writing the equation for a quadratic, y equals a, x minus, and then 2300 would be the first value, squared, plus 152. And to calculate a, I would pick any point, say this one right here, just because I already labeled it. I would pick any point, sub it in for x, sub it in for y to calculate a. So we can use a quadratic as well to model this situation. And it's a guess. We don't have enough data to know. Are these numbers going to go up if we increase the price of sale, the price of the computer? Are more people going to start buying? Well, I guess it would depend on a lot of the things that go with it, but it's possible. So it's possible that it's quadratic. The next one we're going to take a look at is exponential. Could this be exponential? Sorry, cubic. Missed cubic there. Cubic. Yep, it could be cubic. It could really be anything. if I make a cubic, let me just see if I can turn this into a cubic curve here like this. Right, I could say yes, that's a cubic. And for a cubic, the equation would be, so I would use, let's say I'm using this point as my kind of vertex, my center point of the cubic. In that case, that would be the 1700, 164. So I'd have a x minus 1700 squared plus 164, cubic, plus 164. And then I would have to find a, same way as I've always found a. So it's possible to say it's a cubic. And it's maybe a bit more realistic to think that if you're charging this much money for a computer, your sales are going to drop and you're going to start, it is going to start decreasing. So it's possible it's a cubic. The last one we want to look at is exponential. And since that's our focus of this entire unit, I'm going to spend a little bit more time explaining the exponential than I did the other ones. To write in exponential form, we're going to begin with our formula a times b to the power of x. And here's our table, same data. And what's important is the b value. For the b value, it's a decreasing function. Remember the graph we just saw? It would be decreasing function. So we would expect our b value to be between 0 and 1. And now another thing we haven't talked about yet is when you look at these, we put them in order, which is awesome, but they're not going up evenly. 1000 to 1200 is a difference of 200, but then you're only going up by 100, and then by 200, and then by 200, and then by 300. So the x values aren't increasing evenly, so we can't use this formula that we used last year to find the common ratio, which is y2 divided by y1. We can't just do that. We have something a little more intricate. We have a new formula, and if we were in school, I would do the derivation of this formula. I would tell you where it comes from, but it's very similar to the other one, except we have to take into account that our x values aren't the same, aren't increasing evenly. So you have to memorize that formula. And that's the one you have to use when you're coming up with an exponential equation and your x values aren't increasing evenly. You have to use that formula. You're taking good notes, everybody, right? Right. So here, let's try it out. We're going to choose any pair of coordinates from the table of values and calculate b. So let's say I said this is my x1 and this is my y1. Here's my x2, and I don't have to pick the one underneath it. I can pick whatever, y2. I can pick whatever one I want. I sub it into this formula right here. And before you even start this, when you're doing your homework, remember your table has to be in order. When you calculate this, I would like 4 decimal places, please. Once you've done that, I want you to calculate it again with a different pair and again. So 3 times. So I want you to get, and you're writing down 4 decimal places, and you're probably going to find they're very, very similar to each other, but you need to do it 3 times, because if you pick just one pair, it's not a good enough representation of the b value, because these numbers aren't going up evenly. We need to get 3 of them and then average them together. So I want you to press pause now and do that. Okay, everybody's done 3. If not, you can still press pause now. You don't have to just wait for me to show you the answer. I'm not showing you the answer, by the way. I'm not going to give you all 3. I'm just going to go to the answer. Okay, so here's what I hope you got. And if you didn't try it, then you don't know if you know how to do it or not, because you didn't try it yourself. This is the approximate answer. This is 3 different pairs averaged together. We get approximately this b value. So now we have a b value to put up here at the top. In our equation, we now have a b value. We have to find an a value. To find the a value, we pick any coordinate, sub it in for x, y, just the way we've always done. So I'm going to take this first coordinate right here. This gets subbed in, 1000 goes in for x, 189 goes in for y into my equation. Now here's where you have to be able to work your calculator properly. For me, I would calculate this number right here first, and then I would put it in the memory. I love using my memory feature. I would store it in the memory of my calculator. Then, now this one's pretty easy because it's just one number, but I want to do 180 divided by the number that's in my memory. So in my calculator, I would just do 180 divided by MR. It is for memory recall. That's what I would be doing. But especially in university math, the memory button was so useful for me. So if you don't know how to use it, I would suggest you go to YouTube and type in the type of calculator I have. How do I use my memory button? At this stage, you can probably work around it by using brackets, and some of your calculators are pretty good already with the order of operations, but for me, I would prefer to do this than to have to write out the whole number. So this is what happens here if I have to write out the number. And that number isn't even accurate. That's all my calculators show me, but this is, I don't know if it's a non-repeating, non-terminating decimal, but it's a very long decimal here. So if you store it in the memory, you're storing this actual operation as opposed to just storing a bunch of numbers. Anyway, if you don't know how to do that, then you're writing out as many decimals as you see on your calculator so that you're as accurate as possible. Then we divide to isolate A, and we get approximately 230.8. Now, if you picked a different pair, a different coordinate from here, you might have got a little bit of a different answer. And if I were marking tests, the B values might all be slightly different from this, and the A values might all be slightly different from this, but in general, they should be really close to each other. So now we've got the A value and we've got the B value. We're going to put our final equation into Desmos and see how well it fits the data. Remember, your final equation must have a y and must have an x, but the other parameters have to be filled in with numbers. Let's see what this looks like on Desmos. Here is the original table, and underneath it I typed out my formula. So let's see what that looks like. Now think back to those other graphs I drew with the data. I drew a quadratic and a linear and a cubic. Let's see what this is going to look like here. Oh, that's pretty good. I mean, it's no better or no worse than the other options, right? They all had their plus and minuses. An exponential, though, is maybe the best bet for this data because quite likely as you increase the price of your computers, you're going to decrease the sales. They're not going to drop sharply like they did for the cubic, but they're going to continue to decrease. And it's not going to be linear, although this almost looks linear because you can hardly see the curve. I should have zoomed out a little bit more. But this is what the exponential representation of this data looks like. And of course, it passes through the point here that I used. Remember, I used this point to sub in for x and y to find A. So since I used that point, it's going to pass through that coordinate, that dot for sure. If you picked a different one, then it would pass through that dot. This one actually happens to pass through a few of them. So that is how we come up with an equation for exponential data when, especially when our values aren't increasing in even intervals. And that's all there is to it today. That's the end of the lesson. So please make sure you memorize that little formula, that exponential calculating B, that formula that you need for today, and practice some questions.